This episode of On Orbit is brought to you by AVL Technologies, a leading manufacturer of multi-band and multi-orbit satellite communications ground terminals, serving both government and commercial markets. With terminals ranging in size from 60 centimeters to 4.6 meters, AVL provides efficient, cost-effective solutions for voice, video, and data connectivity without the need for specialized training. AVL's innovative and visionary approach to engineering and design ensures the critical requirements of today's missions are met. For more information about AVL's reliable and rapidly deployable multiband multi-orbit satellite systems, please visit avltech.com. That's avltech.com. Thank you so much to AVL for sponsoring this episode, and now on to our interview.
Baiju Bhatt, a tech entrepreneur who's known for disrupting the investing landscape with Robinhood, has set his sights on the space industry. The Robinhood co-founder left his role as chief creative officer in March of this year and announced his space solar startup Aetherflux in October. Aetherflux is pursuing a vision of a power grid in space, one that's not tied to the power grid on Earth, and able to beam power down to remote locations. Baiju joins On Orbit this week to talk about why he wanted to start a space company and tackle the goal of building a power grid in space. He shares his longtime passion for space that started with looking up to his dad, who worked at NASA, and being inspired by the pace of innovation in the commercial space industry today. I'm Rachel Jewett, and you're listening to On Orbit, the podcast that asks, what's our future in space? Hi, Baiju. Welcome to the On Orbit podcast.
Hi, thanks so much for having me on.
Yeah, I'm excited to talk with you today. So in October, you announced your space solar power startup, Aetherflux, and this was really buzzy news in the space industry, partially because you're already a well-known founder, one of the co-founders of financial trading app Robinhood. And I noticed
Mhm.
that when you left the company in March, you kind of hinted on Twitter that you were going to be working on something in the space industry. So, can you tell me a little bit about the background of deciding, why you decided to step away from Robinhood and why you decided that your next act would be in the space industry?
Yeah, so first of all, thanks so much for having me on. My love of space and the space industry and wanting to work on scientific problems and physics, it's kind of been it's been the story of most of my life, and arguably the story actually starts before I was born. So my family moved to the U.S. originally from India, and the reason my family moved to the U.S. was because my dad wanted to pursue a graduate degree in physics in America. So my mom, my mom, my dad moved to the U.S. My mom was actually pregnant when she got on the plane. I was born in America, and I grew up with my dad studying physics at the University of Huntsville, Alabama. And then throughout my whole childhood, he worked at the NASA part of Langley Air Force Base, so NASA Langley Air Force Base as a scientist. So I remember as a kid going to my dad's office and seeing his computer, which at the time in the 90s was like, whoa, he's got a computer, and those big wind tunnels at Langley Air Force Base. And I was just drawn towards it. I was really drawn towards physics through my entire childhood. I went on to study physics as an undergrad at Stanford in my graduate degree in math, and I just kind of always loved that subject matter.
Mhm.
Through the course of building Robinhood, which I co-founded that with my good friend from college, Vlad. We were co-founders, co-CEOs through the company's beginning all the way until late 2020, shortly before IPO, and I stepped back as CEO. And I had sort of passion for space, and in particular was really curious about the commercial space flight sort of revolution that was still in its very early days. And through the entire sort of like journey as an adult, I had always been drawn towards like maybe there's something interesting to do in natural resources. Maybe there's
Mm.
interesting commercial opportunities in space that are going to get unlocked when, it's not just sort of nation states that are going to space, but the revolution of sort of reusable rockets and all that stuff. And so this has kind of been in the back of my head for the better part of my life. I was drawn towards the idea of space solar power when I kind of started asking myself the question, like, what opportunities did I think were new that were going to get unlocked by um, sort of a mass abundant future where there's sort of Starship and the amount of mass that's able to move to orbit, I think is going to be a pretty big step change. And um, I actually think space solar power is one of the first applications that you would pursue in a world where you have mass abundance. So it's been something that has been sort of in the back of my head for a really long time.
Hmm. Yeah, it's interesting. I mean, do you see any similarities between Robinhood and founding a space company? It seems like such a different such a jump, basically.
Yeah. I mean, I think that's on purpose, if that makes sense. Robinhood was an interesting, I think the parallels are as follows. When we started Robinhood, I mean, I had hardly any sort of professional or formal training in financial services. I'd worked at a financial services company for a couple of years and I'd started a few companies, but we were novices. We were newcomers looking at how the finance industry worked. And we took an approach that I felt like from first principles led us to an idea. And we kind of pursued that in the face of like a lot of people thinking that it wasn't going to be possible. And I think in that sort of analogy, like there's a part of this that for me personally is about being a student again, right? It's about being at the early point of a journey and figuring stuff out, which is the thing that really gets me passionate. Um, I would add to this also that as far as problems go, sort of problems to solve go, I don't know if this is on purpose or if this is sort of a pattern that's emerged for me, but I'm drawn towards problems that have that have been around for a long time, where the problem statement, it's not a new one. And I think that was the case with zero commission stock trading because there were, people talking about sort of if there was a world in which zero commission stock trading happened, like how would people interact with the stock market differently. And they've been writing about this for a long time in academic journals before Robinhood. And similarly, like the idea of space solar power is not a new idea. As a matter of fact, it's a pretty old idea from the 1970s. And I think the parallel in my mind is that for both of them, the problem statement's been around for a long time. It's kind of the how that's been a question mark, and people have tried different approaches for what we build with Robinhood, and there's been a lot that's written, although I think there's been less tried with space solar power. So they're both new.
Hmm. Yeah, in terms of space solar power being an old problem, like you said, it's something that has been, people have talked about it and somewhat attempted, but it hasn't been successful on a large scale. So, what drew you to that being the problem that you wanted to tackle?
Yeah, um, I think the reason that I was very drawn towards this problem was looking at space through two lenses. The first one was what are applications that could exist in space that benefit people on Earth, right? Like what are things that we can do that are sort of call them Earth native space ideas, right? So not necessarily stuff that involves like, you know, going to a different planet or going to the moon or something that involves going to Mars, for example. But how can we make something that's going to be useful on Earth? And the other lens is what are distinct commercial opportunities in space that could exist, but that don't exist yet? And I think coming back to the question of like, uh, what are sort of the parallels to what we did with Robinhood in the past is I think one of the big observations there, and this was for me as a human kind of seeing the effect that of what we built had was when we gave people the ability to sort of control their finances, when we put capitalism through the product on people's phones, we were just like kind of surprised and sort of astounded at different points along the ways of how people used it, right? And it kind of left this impression in my mind that if you give people the ability to make money, pursue their own self betterment, they're always going to surprise you. Um, and looking at the space industry through that lens. And one of the things growing up, sort of in this space uh, household that I did, was kind of asking the question, like, what's going on? Like, why isn't cool stuff happening in space, right? Like, it seemed like all the cool stuff happened before I was born in a lot of ways, right? And as an adult, the kind of thought that's crystallized for me is maybe one of the things that's missing in space is like the commercial opportunities, right? Because the space industry, sort of stuff that happens in space that people can work on today, I think falls into a couple of buckets, right? There's telecommunications, right? There's Earth imaging, there's defense activities, there's academia, and I'm sure there's a few others, but kind of asking the question, like, is this the full scope of what can happen commercially in space? And here's kind of the thought that that leads to, which is if we could stand up a distinct commercial opportunity in space, that would create another reason for people to study aerospace, study physics when they're coming out of school, pursue that degree and like want to go work in the space industry because there's jobs there, because there's commercial opportunities there. And as you have more people pursuing commercial opportunities in space, things will start happening faster and you'll see the rate of progress hopefully really astound us. So those are kind of the thoughts.
Yeah, no, I appreciate that. One of the things that stood out to me about your vision for that is that it is focused on what solar power from space would mean for life on Earth. Because one of the things that the industry talks about a lot in terms of like the future space economy or like future LEO economy, like commercial
Hmm.
space stations in LEO, it's I think some of the mining in space will be geared toward bringing some things back down to earth that we can't do here that will be more environmental to do
Hmm.
in space. But anyways, I think that's interesting that it's not space solar power for the future of space, but for what that will enable here on earth.
I mean, I think there's certainly applications for it in space. Like, I think that's certainly an interesting market as well, and
Yeah.
one that we might be interested in the future. I mean, we're I think the goal of doing something that sort of brings space power from from orbit down to Earth is kind of the vision that we have for this, and a little bit more on that. Um, I mean, that's kind of like the future that we think is possible that we want to help create is one where you kind of look at the effect that Starlink has had on terrestrial internet, right?
Mhm.
Like I use Starlink at home. I find it to be really useful. And there's an interesting thing where that capability in space, and you compare it to sort of the ground capability of fiber optic cables. By putting this capability in space, it's actually extremely disruptive, right? And um, it makes having the internet mobile in a way that I think it's still like in the early stages of happening. And we kind of asked the question, like, what would that look like for energy? Like, imagine a world where there's an energy network in space, right? Like a power grid in space, where as we add more satellites, we add more capacity to the energy network. And you can have ground stations potentially all around the world that are able to connect to this energy grid in space and get power kind of when they need it. I mean, that's in my opinion, that's pretty space age stuff. And if we can help create that, that would be a really aspirational goal.
Yeah, that is very interesting to kind of divorce getting power from the power grid on Earth, the possibility
Yeah,
of getting it beyond the power grid.
the
Um,
space power grid.
so what,
That's got a cool. That's got a nice ring to it.
yeah. So what could that mean on Earth? Like what kinds of things do you think that could enable?
Yeah. Um, so maybe it's worth actually sort of rewinding the clock here a little bit and kind of
Mhm.
explaining what our path towards getting
Yeah.
to this fantastical new future that we're talking about is. So, baby steps at first. So the first thing that we're working on, and we're hoping to get this in orbit, either near the end of 2025 or sort of Q1 or maybe a little bit later in 2026 timeframe, is getting a first satellite in space that can demonstrate this capability. So what is this thing going to do? Um, it's going to be a satellite that flies in low Earth orbit. We're buying a satellite bus that's from a company called Apex. We are building the optical payload and the power transmission system, the method that the satellite able is able to find the ground station, establish a link, and then actually downlink the power. Um, we're using largely commercially available, some commercially available off the shelf, some custom stuff for the actual power transmission. So the method of power transmission is using a high power infrared laser. And the basic sort of architecture of this is to try to demonstrate this capability as much as possible with stuff that exists today, right? So satellite bus that exists today, lasers that exist today for a different reason, right? Optical payload, which there's lots of different systems like this that exist today as well. Maybe not for power transmission. And the last part is a ride share to space, right? Which is available today. And with that, we'll have a first satellite in orbit that's able to um, find the ground stations, which we're also going to build. Once it's in orbit, when it's passing overhead of the ground station, as it's flying over, it's in low Earth orbit, so it'll be 5 to 10 minutes sort of within the field of view of the ground station that we're building. We'll send a test signal down to the ground station. The ground station will bounce the test signal back to the satellite. The satellite will use that bounce signal to form a link between the satellite and the ground station. And once the link is established, it'll basically discharge the energy from the satellite into the laser and transmit it to the ground station as it's flying overhead. And once it passes out of the field of view, the satellite will start looking for a new ground station, and the ground station will either have enough sort of energy in it that it needs for its current use, or it'll start looking for another satellite that's passing overhead. So one satellite, one ground station. Satellite is not huge. Um, we're kind of shooting for one of the architectures of our design is we want to have small spot sizes on the ground. So for the first mission, it's going to be, a little bit bigger, but long term, we see the spot sizes in the 5 to 10 meter range. Um, we think we'll get somewhere in that. We'll get to sort of 10 to 10 plus meter range for the first mission. That works. And the reason that that's relevant is because we see the first commercial opportunities for this to be getting power to places that it's really hard to get to,
Mhm.
right? So think remote mining applications, think forward operating bases with the DoD. And I think those are the scenarios where, so step one, get one to work. Step two, um, build for one of these commercial applications where it's difficult to get power, uh, continue to mature the technology, and then long term to be able to compete with terrestrial power.
Mm,
Uh, yeah,
yeah. Why do you, it's very interesting. Why do you think that this has not been successful before and Aetherflux can make this possible?
yeah. I think is a very interesting question for anything new that hasn't happened yet. Well, I mean, like we've talked about a couple of times already. This is not a new idea. It's actually kind of an old idea. And interestingly, I think that there has been, what I'm trying to say, there's been a lot written about this idea with different technical approaches back in the 1970s. And the original idea at the time was to build one really big array as opposed to a constellation of smaller satellites that transmits power using microwaves or radio waves. So kind of much longer wavelength electromagnetic radiation. And if you rewind the clock, and that architecture kind of makes sense, right? You would want to pick an orbit that's far enough from the Earth where you're not in the shadow of the Earth. So those are contemplated to be in a geostationary orbit. And you would pick a band of the electromagnetic spectrum that passes uninterrupted through the atmosphere, right? And so you would pick these longer radio waves, microwaves. The byproduct of that is that you end up with something that's extremely challenging to make in space, right?
Mm.
It's very, very big. And the initial cost to get it off the ground and to get a first demo of the thing requires the whole thing to be put together, right? And so I think it's both technologically very challenging, and it's also difficult to contemplate how you actually make something like that happen. Um, where our approach is built on a different technology stack. And I think the interesting thing is that in the intervening years, there's actually been a tremendous amount of progress on all of the component technologies. And so looking at it in 2024 versus looking at it in 1970 or 1975 or whatever, right? The underlying component technologies are just, there's ones that have gotten really mature, right? So think fiber lasers. We use those in society in a lot of different places, right? Think constellation manufacturing and management. Like Starlink is up there right now, right? Um, in addition to all the advancements that have happened with photovoltaics, right? That's been on a really aggressive maturation curve, as well as battery capacity. So,
Mhm.
and then obviously the last big one, which is access to orbit, which I think Starship is going to fundamentally change. Excuse me. Yeah.
So I can tell that you're thinking about how Starship, if the constellation, how Starship would change rideshare access. Like, would this be something that launches on Starship? But it sounds like from the size you're talking about, it would also launch on rideshare on Falcon 9, just the same, not just the
Yep.
same, you know?
Yeah. Yeah.
Yeah.
Man, it's been really exciting to see. I mean, I goes without saying, but that chopstick maneuver that they pulled off, holy cow, that was
Yeah,
inspirational.
it was crazy. It is
It
crazy
was
to
pretty
watch that.
mind-boggling to watch. Um, yeah, lots of crazy things are possible if you put your mind to it. Is a it's hard not to be left with that feeling seeing that happen.
Yeah, yeah. So what's on the agenda? Like, what needs to happen in the next year? Like, where are you at after just announcing that the company exists a year ago? I'm sure work has been going on behind the scenes. So kind of what are some of the upcoming milestones to get to that first launch in late 2025, early 2026?
Yeah, so we are. I mean, it's just a good old-fashioned company building.
Yeah.
So stuff as little as, or I guess sort of like, getting our lab space stood up, which we're on a video call, so you can kind of see behind me. We've just moved into our lab space in San Carlos, and I mean basic stuff, right? We need to have the equipment to be able to rapidly iterate on component testing and design for our power transmission system. So we've got a lot of work to do on going through the components that we're using, like testing each one of them. There's going to be a lot of components that we want to, make sure that they're space rated. So we're going to be vibe testing stuff. We're going to be
Mhm.
T-vacking stuff. We're going to be testing how different optical components behave under different power levels. We're going to be stress testing the system. We're going to be iterating on the actual design. There's a lot of sort of meat and potatoes engineering that we have to do. We're also gearing up for doing demonstrations terrestrially of the system. So
Okay.
once we have, once we've gone through and developed some of the concepts in the lab, we're going to want to test them in the real world. We're going to want to test things like tracking of our ground station target with our transmission system. Um, we're also going to want to do things like characterize how the power transmission behaves as it passes through the atmosphere. So
Mhm.
lot of testing to be done, a lot of building to be done. Yeah. And obviously working closely with, you know, the regulatory bodies and sort of uh, paving the way for this to happen.
Yeah, that was something I was kind of curious about is the regulatory side. Like, are there spectrum concerns here? But you're talking about transmitting via lasers, so maybe not. I'm curious about what the regulatory angle looks like.
Yeah, so we're engaging with, you know, the folks in DC on this already. And it's early, but we're talking to folks at the FAA, the FCC, and a lot of other folks. Um, it's new territory, right? So
Yeah.
this is a new application, and our approach with this is to be very proactive and communicating what we're trying to do, and working with all the regulators that regulate space to kind of illustrate exactly what we're trying to do, demonstrate the safety systems, demonstrate our approach to safety, um, and just generally being good citizens of space.
Yeah. I'm curious what the response has been for you in the past few weeks after you announced Aetherflux publicly.
Oh man, that's a good question. Um, I mean, I think it's been exciting for me, that's for sure. Getting getting out there that I've been thinking about space for a while, and getting some positive feedback from folks that are like, oh, you know, you're going back to science. That's awesome to hear. Um, I would say my dad has been pretty thrilled, which makes me
Oh, that's
happy.
cool. Yeah.
So my dad is a scientist, and you know, was the one that really inspired the love of physics for me. So shout out to my dad. Sure, if he's listening to this podcast, I'm sure he'll appreciate that.
Awesome.
Um, yeah. It's also, I think the other thing is that it's for me, it's kind of fun to reactivate that part of my brain, the physics part of the brain, and to have, you know, an excuse to go and meet with professors at Stanford and do all that stuff, which
Mhm.
brings me a lot of happiness.
Yeah. I mean, it's different from a publicly traded company that was very well known in the market and now I mean, space is hardware. It's a hardware startup.
Hmm. Again, like I said, that's kind of on purpose. Like I love building stuff, and that was like a big part of the draw of Robinhood is we were building something that people were making a part of their day-to-day lives, right? And the curiosity there of like, I want to try my hand at building physical things. Like you know, I felt like I understood the sort of what it took to build a digital product. I'd done it, you
Yeah.
know, year in, year out at very big scale. Um, and you know, it's interesting because some of that, the way that the desire to build physical stuff started to manifest itself for me was actually in tinkering on cars.
Oh,
So
okay.
that was like my first foray into building physical stuff, and it really, really got me excited about it. I've done some car restoration projects for fun in my garage over the last couple of years.
Neat.
Actually built a kit
What?
car once.
Okay, cool.
Yeah.
So that kind of that got you thinking about what you wanted to do in hardware.
Yeah, I mean it was just very fun. Like I built there's a company called Factory 5 that makes Shelby Daytona, Shelby race car replicas,
Mhm.
and I just rolled up my sleeves and put one of those things together. And then had some more experienced mechanics double check my work. Um, but yeah, that sort of process of being like, okay, you've got a set of instructions and a thing to make, and you're just like staring at them, and you're like, okay, I have to do this. And like, I don't really know what the right tools to do this are. I don't really know how to make this happen, but let's give it a go. And it always takes longer to build physical things uh,
Mhm.
when you're sitting down with a wrench and instructions. At least in car projects, because car parts sometimes don't fit.
I'm curious if do you think the being known for Robinhood and the attention that company is just very well known, do you think that that has been a positive, or are there downsides to that?
Uh, it's an interesting question. I think it is what it is, right? It's mostly positive. It's definitely easier starting a company having the repetitions under your belt. Um, but yeah, I mean, I don't know that I think about that that much.
Okay, yeah.
Yeah.
One of
I mean,
the
knowing how to do it and knowing how to think through the little trials and tribulations, um, and not having to do it all for the first time is definitely makes things happen a little bit quicker.
Yeah. One of my like special interests in my job is people that join the space industry from outside, or companies that are not part of the space industry that realize that they need technology from space in order to
Hmm.
do what they want. So, yeah, I think it's really interesting. And it
Yeah,
just goes to show,
hopefully I can be the beginning of that trend.
yes.
Yeah.
Who are some space founders, or you've mentioned Starship. What are some things that who are some founders that you look up to in space, or things happening in space that you're really energized by?
Yeah. I mean, I'm needless to say, extremely impressed with what SpaceX is doing. Um, I think across the board, it's jaw-dropping what they've been able to do. I mean, that's super impressive. And I say that from the perspective of looking at the aerospace industry, right? And like how they fundamentally turned the space part of it on its head, right? Like there was a landscape of the established sort of legacy big, primes in the space industry, and this little upstart came from nowhere. And look at what it's doing now, right? It's doing incredible things. When we started Robinhood, there was a backdrop of a bunch of existing online brokerages, and kind of seeing them navigate that path um, is super impressive. I think there's a nice crop of folks that are getting started in the space industry now, and I've spent time with a bunch of folks like the folks at Varda, uh, Will and Delian are both very sharp, and I have a ton of respect for them. Um, Also spent a decent bit of time with folks like Bridget from Northwood, who I have a ton of respect for. Um, I think some of the other folks. Oh, of course, the founders of Apex,
Yeah.
which I'm a small investor in, as well as the folks at Reflect Orbital, um, doing another space solar approach, which I wrote a check into. Those guys are very hardworking entrepreneurs. It's cool to see that kind of energy in the space industry.
Yeah, absolutely. I mean, there has been so much entrepreneurship in space in the last maybe 10 years, but I feel like even just in the last year or two, there's been even more. It's like there hasn't been like, oh, there aren't room for new companies because, Apex is fairly new. There's still a lot of new things happening right now.
Oh, I forgot one super important one. Let's give a shout out to my man John Gedmark at Astronis.
Okay.
He's a good friend of mine, and yeah, has been super helpful in helping me think through becoming a space entrepreneur.
Awesome. Yeah. Are is Aetherflux, are you raising capital right now?
So the company is to this date backed by me. We will raise outside capital to be able to make this happen. But yeah,
Any last thoughts on the potential for space solar power? It's been very interesting, Beiju, to hear from you and hear about, the steps that Aetherflux is taking to get there, but also kind of the broad vision.
lot of hard work and elbow grease that needs to happen to make our vision become a reality, and I'm here for it. Thank you so much.
Yeah, thank you. It's been great to talk with you.